Welcome to our channel SkillSnap. So today I am going to teach you all deep learning from zero to hero. This is the best ever course you will find on internet because I am going to teach everything from scratch. So let's get started. First of all, before diving deep into the deep learning course, let's just learn about tensors. Why tensors? I will tell you. First of all, what are these tensors here? Tensors are nothing but the multi-dimensional arrays that are used to represent data in TensorFlow. What is the use of tensors? In the deep neural networks, we use tensors because of two different reasons. That is one, because it helps in automatic differentiation, and the second reason is we can run huge data, we can run huge computations on GPUs using these tensors. You might have this question: when NumPy is there, what is the use of tensors? Yes, NumPy helps run computations only on CPUs. It can leverage computations only on CPUs, but tensors are not like that. It can leverage GPUs to run most efficient computations. So let's get started with tensors. So we have known about scalars, vectors, matrix, and tensors. So first of all, if you take a scalar, any constant or any number which is in zero dimension is known as a scalar. When you come to a vector, it is a one dimension data. If you see the example here, this is a vector. And if you come to the matrix, it is a two-dimensional data. This is how we represent a matrix. Now, when you come to tensor, it is an n-dimensional data. It's a multi-dimensional data. So this is how we represent. So this is just an example, and let's dive deeper. So one more thing, this course is gonna be really interesting, and this is a practical course. I am going to teach more of practical than of theory here. So let's just get started with our Google Colab. And everyone might have heard about this Google Colab. This is a online resource where you can run your Python scripts. And starting with the tensors, as I have discussed, it is an n-dimensional data, and these are multi-dimensional arrays. As we have discussed, it is used for automatic differentiation and it helps run computation over GPUs. Whereas NumPy, it runs computations over CPUs. To get started with tensors, we need one library, and that one library is nothing but Torch. That's the PyTorch library. Okay, so how do we do that? First, let's install the Torch library. That is how pip install Torch. And next, we are going to import the Torch library. Once the Torch library is installed, we can import it. So here, mine, it is installed. I'm just importing it. Why is it taking so long? Okay. After importing PyTorch or the torch, we have to know about the functionalities of it. Why are we using this torch as a fundamental thing to learn about tensors? Okay, why are we using this? Because this PyTorch library helps us in creating and performing operations on tensors. First of all, let's import torch. After importing torch, I am going to talk about a very specific thing, that is a range. So this arrange function is a function that can help us create a vector of evenly spaced values. So the vector starts from 0 as included and it ends at n, which is not included. If you have known about Python slicing or indexing concept, you would have known the start and the stop concepts as well. So the start is included and the stop is not included. Similarly, if we use arrange function here, let's say I will say, let's do um let me add a cell, or let me add a code here. So if I say h is equal to torch dot arrange, of, so I can give a number like how long I want the vector to be. Let's say I want the vector of length 7. Now, if I run it, okay, I have to print it as well. Sorry. Yeah. So I said that I need a vector of length 7 and I printed it. How did I do that? I used the function arrange. And here, if you see, the tensor is being created from 0 to 6. As specified above, the arrange function, it creates a vector of evenly spaced values. So if you see 0 and 1, 1 and 2, these are all evenly spaced values. And it says it starts at 0. So 0 is included, and I said I need a vector of size 7. So this 7 is the stop here, and that is not included, that is excluded. By default, the interval size is 1. If you see from 0 to 1, 1 to 2, 2 to 3, the interval size is only 1. Arrange function we can use in different ways. So if you see here, I have already written code. So first way is the way which we have discussed here. So I will write torch.arrange of 15. So what will this do? It will fetch me, what will this do is it will fetch me an array or vector of size 15 with the numbers from 0 to 14. As we have discussed, 0 is included and the 15, since I specified the size as 15 here, the 15 is excluded. But there are 15 elements here. So the indexing starts from 0 here. And here, there's one more thing. We can provide the data type as well. So here I have given a vector of size 10, and I have asked it to create that vector of the data type float. And here, if you check, what will this result? This x would fetch me a vector of size 10 with floating elements, with the elements of float type. It's not a floating element, it's elements of float type. So basically, you would probably getting 0, 0.0, 1.0, 2.0, and 3.0 as answers. Here you would be getting 0, 1, 2, and 3 and 4. So what would the next one do? I said Z is the torch.arrange. Fetch me the elements which are present in between 1 and 10. So this one, which is there, it says fetch me the data from 1 to 10. So it will create a vector, fetch the vector with data from 1 to 3 and so on till 10. But 10 is not included, so it will only fetch 9. The next task is, I said I want data. Let's say I want data from 1 to 6, or I want to create a vector from 1 to 10 with 0.5 as interval size. So this will fetch data in such a way, fetch data with 0.5 as a interval step between 1 and 10. Now, if I run each of them, let's compare the results. So first one, what we have discussed, it will fetch the data from 1 to 14. 15 is not included since the stop element or the last element is not included. And the data would be of integer type with interval size of 1. So how did we get? We have created a tensor here with the following data. So this is from 0 to 14, interval size is 1, and 15 is not included. Now if you go, we have printed x next. So if you see the x, it is from torch.arrange of 10 and data type we have given as float. So as per our expectation, it should fetch me a vector of size 10 elements with the float values as 0, 0.0, 1.0 and 2.0. So similarly, we got the output as 0, 1, 2, 3 till 9 point. As we know, the last 10 is not included. And for Z, what I have specified is from the range of 1 to 10. Now it will give me all the elements with the range of 1 to 10. So here, when I specified the range 1 to 10, it says I will include 1, but I will not include 10. So we have the elements from 1, 2, 3, 4, 5, 6, 7, 8, and 9. Next, torch.arrange of, I will say the range is from 1 to 10, but with an interval size of 0.5. You can see first element is 1 and the second interval size with 0.5 is 1.5, next 2, 2.5, 3, 3.5, and so on. So this is how the arrange function in the torch library works. Next, we have the function that will help us define the number of elements in a tensor. So that function is nothing but the numel function. If you see here, the numel function, it will define the number of elements in the tensor. Initially, I have initialized y with the torch.arrange of 15. So let's see first of all if the numeral function is returning the correct answer or not. If I do y.numeral, it should return me answer as 15. Yes, it is doing that. Now if I say x.numeral, it should be returning me the size of 10 since I initialized it with that uh, 10. See, it is giving me 10 as output here. The next thing is very common that we find out the length along the axis in which the data is there. So to find out the length along the axis in which the data is there, for that we use a function called shape. Now if I do the y.shape method, this is the y tensor which we have initialized or we have created or generated. So I say I want to know the shape of this tensor. So if I say y dot shape, probably it should give me the size that is nothing but 15. This this is how we get the size of the tensor using the shape method. The next method is the reshape method. So reshape is nothing but we can change the shape of the data or the shape of the tensor without altering the size of the values by invoking the reshape, which means I will have all the, like, let's say I'm taking the y1 which we initialized y tensor where we have 15 elements, and now I want to resize that 15 elements. As we have seen, the size is it's 15 and it's in like a one-dimensional vector. I want to convert that to two-dimensional vector now. I want to make that 15 elements in the form of a two-dimensional vector, so that I will use the function reshape. What will this reshape do? Y dot reshape of, I gave the values as 5 and 3. So this will become 5 rows and 3 columns. So these 15 elements which were there will become 5 rows and 3 columns. Now if you go and run this cell, see, it has arranged all the tensor elements in the matrix of 5 into 3. This is how reshape works. Now in reshape, let's say I don't want to we can just initialize a -1 either in the column or in the row without specifying the size of it. So if in this case where I have put uh, I have initialized a tensor of size 12. Now I want to reshape it. When I'm reshaping it, what I want to do, I am clear about the the number of columns that has to be. But I am not sure about the number of rows. I do not need to do any computation. I simply put -1 and I put 3 here. Okay. Now if I run it, What can you see? I have just given 3 in the columns, but I haven't specified that it has to be of 4 rows. So the tensor will automatically do calculations for that. Similarly, you can also specify -1 in the um, column vector, knowing the rows. I only said I want a, you know, 1 second. Let me run it again. I only said I want a matrix, I want to reshape in such a way that I want 6 rows, and I didn't specify about the column. So it will automatically calculate and take the number of rows, number of columns needed here. So it created a matrix of 6 rows and 2 columns here. Now, generally, when we are doing computations, we need, we need to set the tensors to either completely zeros or to completely ones. This happens when we are doing the weight initializations and something like that. Here, what can we do is, let's say I want to create a tensor with 3 different matrices of 4 rows and 5 columns. Okay, and all of these I want as zeros, and all of these I want as ones. So if we see here, I have put I have used torch.zeros method here. So this is the function which will help us to create a tensor with all zeros. If you see here, I have given us, I want to see here. And similarly, we can create a tensor of all ones only. I can probably give, uh, you know, I can probably give any of the numbers in the dimensions and use the ones function to generate a tensor with all ones. Now, if I run this I have got a tensor with, you can see I have given the shape as 3, 4, and 5 here. So I have got 3 matrices, and all of these have 4 rows and 5 columns. So this is how it works. Now, similarly, when I ran this for print of y, it will give me all ones here. See, I got 3 matrices with, uh, you know, 4 rows and 5 columns. This is how you can initialize a tensor to all zeros or to all ones. The next thing is the random initialization. Whenever we have to play with parameters in deep learning, we will probably initialize with the random values. Now, rand is the function or the method that is used for random initialization in tensors. So, I can simply give as torch.rand of, and I can give the size, or I can specify the shape of the data or how much I want to generate. So if you see and print of R I did, I have created a, or I have generated a tensor with size, I mean 5 by 7. So these are all random values. This is how you initialize random values in data. Now you can create tensors from normal matrices as well. Like I have a 3 by 4 matrix. Now I want to convert it into tensor. So tensor is the function that is used to convert any kind of data to tensor format. So if you see, or tensor object, you can say it's not a tensor format, it's a tensor object. So I am initializing torch.tensor, and I have given my matrix here, and I said convert this, convert this matrix, or convert this, the data of vectors, or collection of vectors into tensor object. Now, when I run this, you can see it has created a tensor, and it has converted from the matrix to type of tensor. And one more concept is, as we have discussed earlier also, the start and the stop concept. So slicing and indexing in tensors is, it's just the same as we do in Python. We include the start and we exclude the stop. As you can see, this is bolded. We include the start and we exclude the stop. Like if I say I want to fetch the last element, I use -1. And if I want to fetch details from the first to like the third one, like what will is from if I give it from 0 to 2, it fetches the 0th row and the first row. And as I said, 2 will not be included. If you can run and see, these two things we get, because A we have initialized as this here. Now if I'm going to run for this last element okay, let me show you here. If I want to fetch the last element, I would get this row as the output. And if I have to fetch the details of the first two rows, I have to give it from 0 to 2, because the indexing starts with 2. Now I have got 1, 2, 3, and 4, 5, 6, which are nothing but the first two rows of this A tensor. Now, not only fetching, we can even rewrite the fetched code. So, I mean, it's not rewrite, we can actually replace the values here. So, what I want to do, I want to replace the third row, uh, third row, second element, or the third row, second column value with 100. Or let's say I want to edit the first row, second value with 100. And if I print of A, now this has been replaced with 100. So this is how it works. Thank you for watching the video. Please do like, share, and subscribe. Your subscription is a motivation for me to keep going forward. I will bring more videos on this. Thank you.